Hello, I'm Rob Reiner from Tachyum. Today we're going to discuss the virtual memory translation subsystem of the Prodigy Universal Processor, the advantages of 64K pages, and demonstrate these advantages by running a database application on our Prodigy emulator. A page is a minimal amount of contiguous memory which the CPU and OS translate from the virtual address space of a running process to the physical address of DRAM available in each system. For decades, the default translation page size on most CPU architectures was 4 kilobytes, but with the amount of data being processed and application sizes growing, adhering to 4K page sizes leads to increasingly larger overhead. With Prodigy targeting the cloud, AI, and HPC markets, it will constantly be crunching large amounts of data. To maximize efficiency, we made 64K page sizes our default offering. We still support 4K pages as a backup for customers who can't immediately adjust their application. Converting to larger page sizes is an industry trend, so Tachyum is not alone in eliminating translation overhead from its CPU processing. To facilitate virtual to physical address space translation, a CPU typically has two special caches called the Translation Look-Aside Buffer, or TLB. One cache is smaller and faster and closer to the execution units, and the main one is larger but has longer access latencies. The number of entries in those caches are limited, and when the translation is not cached, it's derived from translation data structures in DRAM. The process of finding the translation entry in DRAM is called page walking. DRAM is the slowest memory in the CPU memory hierarchy, and accessing the correct translation entry typically requires multiple reads from DRAM. So missing TLB caches is quite expensive, and on large applications, page walks typically cost about 10% of the processing time waiting for translation results. Using 64K pages allows the TLBs to hold translation data for 16 times larger virtual memory. The OS typically organizes translation data to be allocated on demand, so it doesn't waste too much extra memory to hold all possible translations, even if they are not yet used. But on demand means that on top of page walking overhead, each translation that is not yet present in translation data causes a CPU fault which updates the data structures. Fault processing is also quite costly at multiple thousands of CPU cycles. Using larger page sizes cuts this overhead as well. Let's demonstrate the overhead reductions by running benchmarks on Redis DB. Redis is an in-memory database that usually serves as a cache between applications and an SQL database. The SQL query and corresponding results are stored as a key-value pair in Redis. So when the application makes the same query, Redis provides the result. We will run the benchmark for 1,000 rounds with accesses for 4 clients and 1K requested data size. We will run it first on the system configured with 4K pages and then with 64K. As you can see, the amount of page faults observed is 14 times smaller with the 64K configured system, very close to the theoretical maximum of 16 times, validating the overhead reduction, which allows the CPU to spend its time more efficiently on its main task of data processing rather than process maintenance. That concludes our demo. Thank you, and be sure to stay tuned for future Prodigy updates and milestones.